Hidai or Vigan, can you check once if we are live? I think we are.
Yes, we are live.
So
Yes, we are
yeah,
live.
so Pundrabhat, you can start. So yeah.
Yeah, okay, sure. Hello, everyone. Welcome to this talk on how Indian languages can benefit from the AI wave. Our speaker today is Professor Arnab Bhattacharya from the Department of Computer Science at IIT Kanpur. He's a renowned faculty member from our department at IIT Kanpur, and he got his PhD from the University of California at Santa Barbara. His research encompasses various areas within computer science, including data mining, database systems, and bioinformatics. He is actually a renowned leader in the Indian NLP scene. He focuses on analyzing statistically significant patterns, spatial and temporal databases, scaling queries, and image data management for biological applications. He has received numerous prestigious awards, such as the IBM Faculty Research Award and awards from Yahoo Faculty Research and Engagement Program. He is also involved in creating. He was also involved in creating BhartGPT. Um, like, if you might have heard of it, like from various news sources, it's all the hype right now. The This project also focuses on developing technologies that improve the understanding and generation of text in various Indian languages, making digital tools and services more accessible to a wider audience in India, given its rich linguistic diversity. He also has an extensive publication record with a number of papers presented at various prestigious conferences and journals. Now I hand over the stage to uh, Professor Arnab Bhattacharya. Sir.
Thank you. Thank you very much, Pundabrata. Thank you, the AI initiative, for inviting me as a speaker. I'm honored to be able to speak to this. I'll essentially, we all are facing this AI wave, and I thought one of the important things is that we are grappling with this question that the AI wave, is it for Indian languages, or is it really for the English and other things? So I'll just try to give a very brief overview of what my sense of the whole field is, and you're welcome to ask questions on that. So, so first of all, let's start with trying to understand what exactly language is. And now, whatever I'll be saying, mostly I'll be using the Indian languages, Indian theories of language. So there are these Western theories of language, and then there is this Indian theories of what language is, how do you communicate, what is a word, what is a sentence, etc. So we all understand that language is essentially a encoding of communication. Language is needed only because one person wants to communicate her mental form of the idea to another person. Otherwise, there is no need for language actually. So it's a communication. It's primarily encoding for communication, right? And in as I said, if you read Sanskrit texts, etc., there are 4 phases of this idea, mental form. So para is the idea that gets inside you. It's what you, and then the pashanti is you think about it. Madhyama is just before the speech, which is called Vaikhari. Vaikhari is what you can actually hear, and that is what is comes out. But to be able to speak, you need all these stages. You first have to have a mental idea, then you need to push some air out of your body from the vocal cord and all of this. This is part of that. Now, of course, we are dealing with natural language, which is very complex due to ambiguity, multiple word meanings, context, idioms, sarcasm, intended meaning, all of these things. Right? So this NLP is a field that tries to understand a natural language. Okay, and this is quite different from, let's say, a programming language where rules are very clearly stated, and it's easy to write 100% correct parsers and compilers and all of these things. So essentially, one may ask the question, then natural language, how does one learn a language? There are 2 views on this. One is that we humans have an innate capability of language, and that therefore that is what differentiates us from other species which cannot speak. That is one thing. The other is that language is learned mostly by exposure to usage. And this is essentially the deep learning view, right? I mean, it's essentially the same idea that AI, right? You are exposed to one language for long because your parents speak it, because your household, because your friends, because your relatives, all of them speak it. That is how you learn a language. And so essentially just by exposure, right? Grammar rules, etc., come much later. So the language skills, if we just tabulate it there are two things. Now in modern age, what is meant mostly by language is what is written, because text is much more easily available. Text is what you can see, etc. But language is more about speech. Actually, it's still more about speech. And speech have the skill of listening. If I can listen to what somebody else is saying, and can I understand this, or can I speak it? And text is reading and writing. Now, of course, knowing a language involves several studies. You need to know this phonetics and phonology, because this is basically sound. Then morphology, what are the words, what are its parts, how do you, when you hit a new word, how do you understand it? And syntax between the words, how they're, what are the relationships, semantics, of course, the overall meaning of a word, overall meaning of a sentence, etc. There are some higher order things beyond a sentence. For example, pragmatics, right? I mean, I'm speaking a sentence not just for the sake of speaking a sentence, right? I am trying to connect different sentences. There is a relationship of the meanings to what I'm intending to do. For example, I'm intending to tell you about how languages are studied, right? That is my whole intention. That's my pragmatics. And therefore, I'm breaking it down with different sentences, which in turn is broken it down to different words, etc. Right? Discourse is, of course, this whole discourse, I mean, organization. How I'm going to do that? I am not just saying the sentences randomly. The sentences have a particular organization, particular order, or flow of knowledge or thought, right? So these are some of the things that one needs to know, that when you're studying a natural language, these are some of the parts that can be broken down into. So the language units, characters are, of course, the basic units for written language, and phonemes are the basic units for spoken language. And these Indian languages have a nice one-to-one correspondence between characters and phonemes. So if I say ka, I have a phoneme which says ka, and I write it down as a ka, correct? So Sanskrit is perfect in the sense that if you pronounce, the pronunciation is perfect. So just from a pronunciation, you can write it down without any loss. Okay. Indian languages are also quite good, but some languages have over the time lost it. Bangla, for example, Bengali has lost it a lot of more, because we pronounce that O very differently, etc. Ohomia, to a very little knowledge I have of Ohomia, but to the best of my knowledge, Ohomia preserves it quite well. Odia preserves it quite well. But Hindi, Bangla, all of these have kind of lost it. So then comes words or pada. Actually, in Indian theory, this is called pada or padam or whatever you want to call it. These are combinations of characters that have a meaning. Now, this is, of course, we can argue endlessly about what does it mean to say it's a word. And in processing, in computer natural language processing, they call it tokens. Tokens are ideally words, and words are ideally tokens, but of course, because of different ways of finding tokens, they may not be exactly words. So one important thing, this is a very important thing for Indian languages, and this we should understand, is that this writing down of words, so language, when it is written down as a text, there are some typographical conventions. For example, we tend to separate words by a white space, either a blank or some punctuation mark, etc. But remember, when we are speaking, when you are hearing to somebody, we do not do that. For example, if I say the sentence, I am now talking. So I do not say I blank, am blank, now blank, talking blank. No, I am not speaking like that, right? In fact, I'm not even giving any pause. Just all the words come in one flow. Therefore, and it's a kind of very interesting that when I listen to someone of which the language I know, this lack of white space separation or lack of separation between words does not hinder me. I can still understand where to break the words, where not to break the words, etc. Of course, again, if you have noticed, when we are learning a language freshly, when you're learning a new language, then this actually hurts you, because then you are trying to see, for example, if you watch a movie in a language that you are just trying to learn, you will understand some of the parts, you will not understand some of the parts. You wish they were speaking it more discreetly, right? This word, this word, this word. Probably because you can make out the words, but this connection of the words, where it does one word end and where does one word start, it's actually hard. And the whole phenomenon of sandhi is such a prolific phenomenon in Indian languages, starting from Sanskrit to every other language, is a speech convention. I would never require sandhi if I were only writing it down. Sandhi is a speech convention. Why is it a speech convention? Because you see, if I say tatha and api, if I say it like this, it takes more time. I have to kind of spell it out. But if I say tathapi, I'm saying the same things. I'm using lesser amount of time, and it's not a problem for the native speakers and native listeners, right? So sandhi is this word boundary where I'm putting two characters together and speaking something else. When I say ityadi, iti adi, I'm not saying iti adi. I'm just saying ityadi, right? That is the thing. Samas, there is another phenomenon called samas, which is very related. So, and school students often make a mistake of what is sandhi versus what is samas. Samas is a semantic combination. Now, samas may involve sandhi, may not involve sandhi, but it's a semantic combination. When I'm taking two words together, I am semantically combining them. I am making another word which has a meaning that is linked to the meaning of these two words, but it has a separate meaning. It is a separate word altogether. Sandhi is not a separate word. Sandhi is just a convention of speech. Okay, this is, I mean, in Indian languages, this is very heavily done. In English and other things, it is there, but very, very rudimentary. In fact, so rudimentary that you can almost make a hard-coded list of that. Yeah. Now, word meanings. As I said, word is something that has got at least one meaning. Otherwise, it's not a word at all, right? If I just say XYZ, it's not a word. Why? Because it has got no meaning. Of course, it's a combination of characters, but it's not a word. Now, a word may have multiple meanings, which is called the phenomenon of homonymy, and multiple words may have the same meaning. Okay, this is called the synonyms, right? Now, again, we don't realize it because we have been not trained to realize this. Indian languages, although this phenomenon of synonymy is there, but it is slightly different than just saying same meaning. I'll give you an example from Sanskrit. See, all these words, vanni, jalanaha, pavakaha, sushma, agnihi, these are all essentially fire, right? So in fact, if you look up any Sanskrit dictionary or any dictionary, or even in Ahomiya, Bangla, these words can be used as is, but not a problem at all. You are only listing it down as fire, and so these are actually synonyms. But if you go back to how these words were actually formed in the first thing, there are nuances, and these nuances are very, very important for, let's say, Sanskrit processing, because how you use it in a slok, how you use it in a text, actually depends on the nuance of it. What exactly is the thing? For example, I'll just tell you, vanhi actually means vahni, vahan, so something that carries. Okay, because air carry fire carries whatever it is doing. It is the carrying it there. Jalanaha, this is probably more easy. It actually burns. Pavakaha, it is something that purifies. So the fire that we see have got these different names because of these different nuances, because of the different functions that it follows. So when I'm saying I am doing a yajna, I should be rather using pavakaha, because the point of yajna is probably to purify something. I'm putting something in that power, this thing. I mean, I can use any of the other words, but a real good Sanskrit scholar will use the word that has got the exact meaning that it is intended to do. So in that case, it's not really a synonym. But for common usages for other Indian languages, this is more or less similar. Just to complete, Shushma, that is something that dries, and Agni, that goes forward, upward. So forward is upward. Agre gachati, right? So Agni. So as you see, we can all use it as fire, and we are otherwise we can retain all of these things. One crucial thing, if you have noticed on this slide, is that when I take it to another foreign language here, which is English, fire, all these cultural nuances are lost. See, I can use, this is from Sanskrit directly, but this, if I speak like this to a Hindi knowing person, to an Ahomiya knowing person, to a Marathi knowing person, to a Malayalam knowing person, all of them will understand the nuances. All of you, whoever is listening, probably have understood the nuances between Jalanaha and Pahakaha, correct? But if I just translate all of them to fire, then this whole richness of the language, the Indian languages are so rich in terms of this subtleness of meanings, that is lost. Now, translation of all of this will just become fire, and the reverse translation will take probably one of the words Agni, and fire will be always translated to Agni, which is the other words are going to get lost over time, and the nuances are not captured. This is very important for Indian language processing. Okay, now some other typical things, types of word meanings. So, I mean, the essential nature of a word is called Shakti or Vitti, meaning its power to use it, right? Where it can be used. And there are three main types. First is called the Avidha, which is the primary meaning. Avidha essentially means ghata. Ghata means spot, because it's Juru. It just means that, nothing to be done. Then something called yogic, yogika sabda, like manushvatta. If you understand what is manusha, and then you can add this twa to it and can understand what is manushvatta, right? You can understand vidya, you can understand alay, and then you can make a samasta patya, vidyalaya, so abode of vidya, right? Again, if you just use the translation school, this subtleness in the meaning, this nuance is lost, right? Then something interesting, pankaja. Pankaja meaning literally it means something that grows in mud, right? But now I just cannot use it for anything else. Pankaja means only lotus. It of course grows in mud, but that's the only thing that is being used for pankaj. Right? That was avidha. Lakshana is the implication. Sometimes when you use a word, you don't take its literal meaning. You use it for something else. For example, this word kushala. Kushala means skilled, right? But originally, it came from this notion that there was kush grass. Kush grass is very sharp. So to cutting kush grass was a skillful job without cutting your own fingers and getting hurt, etc. So therefore, people who could do it was called kushala. But later on, because it was essentially a skilled job, right? So now kushala essentially means skillful person, right? In anything kushala, anything skilled. Then another example is that kakebhyah dadim raksha. So basically, English translation is protect card from crows, right? Now, what is the situation? So suppose there is some card which is outside in a courtyard, and you are asking somebody that, well, it is when it is outside, so you protect it from crows. Now, does it mean only crows? Does kakebhyah, kaka means only crows here? It not, right? It essentially means crows, etc. So crows and other birds and dogs and cats and everything, essentially you protect it. Right? So kaka word here, it doesn't just mean this is crow. Right? Then Chandramukhi. Chandramukhi is a very, very what you call common word in poetry and all of these things. Chand jaisa mukhra, right? Do you really mean that the face of this lady is actually like moon? Not really, right? It's the moon's qualities. Maybe it's the beauty of or maybe it's a round shape, whatever. I mean, there's something else that is what is being imposed on the face, right? So Chandra here doesn't mean Chandra actually. It means the qualities of Chandra. So that's the Lakshana. Then the third one is, of course, more subtle, and I don't think any natural language processing is anywhere close to understanding this. This is called suggestion, Vyanjana. So Surya Astaha. So if I just say the sun has set, now it can mean a lot of things under a lot of different circumstances. For example, if this is being said by one friend to another at the end of the class and all of this, this really means that, chalo, it's time now, the day is over, let's go and have some fun, etc. Right? Suppose this is being said by this Rakhal Balak, right? What you call this cow herd to another Rakhal Balak. That means that, well, now Surya is Astaha, the day is it, so let's pack up and leave, right? The same for in a factory, etc. Maybe in something where this a person is saying to another person, Surya Astaha, so remember, now it was your time to go. So when I say Surya Astaha, I'm saying the sun has set, but that is, I'm just using it as a suggestion to say something else, right? I'm just reminding you. For example, I have been talking, and now if the organizers say, Sir, 5:30 baj gaya, it's really not to tell me that 5:30 baj gaya, right? It's basically to say that, well, you have to do it faster, or your time is up, something like that, right? This is a suggestion. Okay, now let me change gear. Let me go to AI models from language, and I'll go a very brief thing. I'm not going to go into the technical things of it, but whatever I'm going to say, it's important to understand just the overall framework so that you can appreciate what are the things that can be done for that, what are the things that AI can do for Indian languages. So the first thing is something called recurrent neural networks. Essentially, it's recurring patterns, and the same task is repeated. This is very productive for any language task, because a sentence, you can always call it as a sentence as a repetition of words, right? So I'm trying to understand one word, then I'm trying to understand another word, and so on and so forth. So the same task is repeated. That's called recurrent neural networks, and this is coming directly from artificial neural networks, of course, with some important changes. The most important change is that the output of the TF word, whatever you are trying to do with the TF word depends on whatever you have done so far. It depends on the history. So it captures history in some form, and that is what history is passed on to the next thing. That's the most important. Okay. All right. So then there can be bidirectional recurrent neural networks, which is not just the past, but whatever I'm doing with the word depends also on the words that follow it. So also from the future. So bidirectional. Yeah. So the problem of RNN is that, well, because of computational processing, you can look into only so many history words. Maybe you can look into 3 words or 5 words, etc. But sometimes you may leave out important information at the beginning of a sentence. Suppose at the beginning of a sentence there was some important information. So RNNs cannot, the plain RNNs cannot capture it. And then there is this mathematical technical problem, which is called vanishing gradients. To keep that, basically you need to understand information from a longer sequence. And for that, there are 2 variants, LSTM and GRU. I'm not going to go into the details of it, but this is important to know the names, that LSTM and GRU are just RNNs with this long-term memory. Okay. So, and then the big leap came in this language modeling, in this AI for NLP, in this task called the language modeling. So the language modeling is essentially a task that I give you some part of the sentence, you have to complete the next word. This is called language modeling. Okay. So for example, if I give you this sentence, so long and thanks for all, then people who have read the Hitchhiker's Guide to the Galaxy can very easily say this is so long and thanks for all the fish. But can a machine do it automatically? In fact, this is actually quite a difficult sentence because it is very unexpected. Anyway, but so the whole idea is that keep generating the next word. So keep generating the next word. If you can keep doing it in a robust manner, in a systematic, semantic manner, then you are generating sentences. And you see where this generative AI, all these things comes, right? So you can understand the language and can keep on generating. Okay. Then this is what is called transformers. From RNN, this is went to transformers. See, RNNs use a bit of history, and transformers use the entire history. And this is called self-attention networks. Why? Because whatever has happened in the past, you see these connections. Let's say you are at this 4th word. You are trying to predict something about the 4th word. You are taking help of all the previous 3 words. and you have some attention. Some attention is essentially some weight that you are looking at this, right? From all the previous words. This thing is called a transformer. Okay. And then using a transformer, we can make something called a transformer block. So transformer block is what is being used in actual architectures. But essentially the main idea is the self-attention layer. This is the attention layer. Okay. All right. Then the language modeling using transformers is exactly the same as in RNN, but instead of an RNN here, you are just replacing by a transformer. So nothing changes except the middle point you have plugged out the RNN and fit in the things. Everything else in the machine remains the same. All right. The next important leap is something called the encoder-decoder model, and this is very useful for translation kind of tasks. But essentially, what happens is that the encoder accepts an input sequence. So, let's say I am translating from Ahomiya to Sanskrit, right? So I am encoding. I am passing on the words of Ahomiya. That is, I am doing some encoding to it. I am learning some context of it, some vector. Then, using that context, I am generating the Sanskrit sentence. I'm decoding, right? So this is called an encoder-decoder model. So the context vector represents the entire Ahomiya sentence, and from that you are generating this Sanskrit sentence. And note that this n and m need not be the same. So the length of the sentences need not be the same. So you can just generate an arbitrary length of output, right? Then what happens is that instead of that, you can augment this encoder-decoder with something called attention. This is called a cross attention, because now the decoder will also look into each of the encoder words separately. In the previous model, it was just looking at the context that was learned from the entire thing. Now it is looking at the context as well as looking at the encoder words. This is essentially attention, but it's cross attention because the decoder is getting attention from the encoder. That's all. Then, using all of this comes BART, B-E-R-T. Again, this is a landmark model. It's a standout model in this field, and it starts for bidirectional encoder representation. So BART is essentially an encoder, just an encoder without the decoder part. And it uses bidirectional, because RNN, remember, we were seeing this bidirectional thing. And so in transformers also, you can do this bidirectional thing, not just from the past, but also from the future. Okay. And then so now the big thing comes is that why is it all very good for computational processing? Whatever I'm doing, why is it good for computational processing? So the thing is, this is called a masked language modeling task. Now you see the actual sentence is so long and thanks for all the fish. Okay. What is being done is some of the words are masked. That means it is replaced by a mask. I mean, just some arbitrary. This is something just called a mask, right? Some of the words, and then some of the other words are replaced by an arbitrary word. Okay. So now instead of this input, what is given, the input is given is so mask and mask for all apricot fish. That is what is being passed. Now the task of the encoder is to say, can it get back saying that, see, so mask and makes no sense in the language sense. So can I reconstruct it back saying that this is so long and then can I reconstruct that so long and thanks? And then again, so long and thanks for all apricot fish probably makes no sense. So can I reconstruct it saying so long and thanks for all the fish? Okay, this is the task. This is the masked language model. Now, the important part is this is all done in a machine learning way. This is all coming from the machine learning paradigm, right? And essentially in machine learning, what happens is that the model requires something called a training data, correct? You need to pass on some training data, and the training data has to be labeled in the sense that for the training data, I know what the input is. I must also supply it with the correct output. Okay. Now, this is the hard part for any machine learning thing, is to generate this training data, because this requires a lot of training data. For example, think of a very simple task that I have given you a basket of fruits, and you need to tell me which one is orange, which one is mango, which one is guava, all of these things. Right? How do you teach this? You must first pass it many such fruits, many such mangoes, many such oranges, many such guavas, etc., so that I can understand which one is a mango, which one is a guava. So these many things is typically hard, and typically that requires a lot of resources and all of these things. Now what happens for this masked language model is this generation of training data is actually easy. Why? Because you take a corpus. What is a corpus? It's just some text, some collection of text. You take a corpus and you take a sentence, then you take and then you randomly mask these things. This is just automatic task, right? And then each sentence becomes a training data, right? And this training data you have generated automatically because you know the actual thing, right? Because you've taken it from an actual corpus. Therefore, you know that if I pass this upper line as the input, the output is the lower line. So I know exactly the input-output pair, and I can do it for all the sentences in my corpus. I mean, a corpus typically contains 1 million sentences or something like 10 lakh sentences, right? So I can very easily get 10 lakh training data. Correct? This is where the success of masked language model was. So it could generate a lot of such training data, and therefore, because it can generate large amounts of training data, it can have larger and larger models. The machine learning models, the deep learning models can be larger and larger with more and more number of parameters because it can generate more and more number of training data. This is where the success of this AI wave is. Okay. Now, of course, as I said, BART is just an encoder. How do you use it? Well, what you can use it, you can take the output of a BART and can modify it for the particular task that you have. This is called fine-tuning. Now, instead of trying to understand it the computer science way, maybe it's easier to understand it the human way. Now, suppose I tell you, do you know Ahomya? You will say yes. But how will I know that you will know Ahomya? I'll test it on some task. So I will say, for example, given an Ahomya sentence, tell me whether this is a positive sentence or a negative sentence. If you understand the language really well, you can say it is yes, no, and you will be mostly correct, right? Then I will say that, okay, here is a word. Tell me which of the other words is a synonym. So you will be able to say this, right? These are tasks, right? Now remember, how will you do this? You will probably need to little bit of fine tuning on that. Remember your school exams. You were all, when you were learning a language, these were all asked of students, right? So that part is a fine tuning. Just for the task specific thing, you are doing a little bit of understanding of this. But when you said you know Ahomya, you did not, when you learned Ahomya, maybe you did not think of it in these terms that I have to do a sentiment classification later on and all of this. You just learned the language by reading the language, by speaking the language, etc. That part is the encoder part. Okay. So the encoder part is just learning a language, and the fine-tuning part is doing it for task-specific things. Okay. All right. Then comes this very important thing is called instruction fine-tuning, right? Now, in addition to just the input and output for machine learning tasks, there is an instruction that is provided. Correct? So I'm saying, please correct this grammar. So suppose it's a grammar correction task. Then you say, please correct this sentence. Then I give an input, which is a wrong sentence, and the output is a correct sentence. So this first part, which is saying an instruction, that is the important part in this instruction fine-tuning. And the instruction fine-tuning is only a decoder model, right? Because I have given you the instruction, I have given you the input. That is all known, and you just have to output. Correct? So that's the decoder only model. GPT, we all know ChatGPT, etc. This is exactly how it has been done, how it has evolved into that. Chatbots. So chatbot, ChatGPT, etc. They are very successful. Of course, who all have not used chatbots? Now ChatGPT everybody has used. In fact, it is so much used that we are worried. but people have to remember, you all have to understand that chatbots suffer from multiple problems. What is the first problem? The first problem is called hallucination. It gives wrong answers. Not only wrong answers, it sometimes mixes up languages. So if you're just able to read this was done, actually an experiment done by one of my students. If you say Arjunasya Pitakaha, if you remember even very basic Sanskrit, you will understand there is a question in Sanskrit which says, who was Arjun's father? Now you look at the answer. The answer is very, very interesting. It says, Arjunasya Pitaka Naam Raja Pandu Tha. So two important things. First of all, the question is in Sanskrit. It tries to answer in Hindi. Why is it doing that? Because the script are the same. Because they both use the Devanagari script, so it is doing. However, it is not even able to give it an answer in correct Hindi, because in Arjunasya, that cannot happen in Hindi. That is a Sanskrit word. That is a Sanskrit construct. So Arjun ka pita, if it had said, then I would have still granted it, right? But it is not even trying to do that. So it is mixing up languages. It is not even understanding that there is Sanskrit to this. It doesn't know this language, right? And it may give wrong answers many, many times. Hallucination, I think. There are other problems, something called jailbreaking. Jailbreaking is you are prompting this chatbot to tell you stuff that is immoral or illegal. For example, this was actually done an experiment. You can actually ask it more and more questions, and you can say how to break somebody's phone, how to hack into somebody's phone. Right? It will actually, if you keep on questioning, it will actually tell you the entire procedure. Android phones, how to hack it. Okay, this is called jailbreaking. So it is, you are manipulating this to do something that is it is not supposed to be doing. Right? And a very simple and a very similar issue is called prompt injection. So you are manipulating it through these chats somehow to reveal more information that is intended, or you are using this chatbot for something else that what it is intended. These are very, very dangerous problems actually. If you are using more and more ChatGPT and this is going to everybody's hand, then you see now with this jailbreaking example, essentially I am not breaking the law. I am just playing around with ChatGPT, but I know how to break your phone, how to hack into your phone. Whose responsibility it is now? Is it? I mean, isn't it the ChatGPT's responsibility to protect against such things? So chatbots are, I mean, it's a very dangerous toy. I would say. Well, it can do a lot of important things, but not so easy. Okay, now I will just covered languages, covered AI models. I will just very quickly give you a brief overview of why Indian languages, how is this space connected to Indian languages. Now, there are certain features of Indian languages or peculiarities that are almost unique to Indian languages only. For example, our names are not just names. So I'm sure almost all of your names have got some meanings, correct? So for example, my name Arnab, it has got a meaning. Everybody, almost all of this. So I can use them as a meaning, I can use them as a name, sorry, or I can use them as a common word. For example, just read this sentence. This essentially means because he was black, he was named Krishna, right? I'm assuming the typing of Ahomia is correct. Please do forgive me if there are a mistake. But basically it is saying that because Krishna Ovara Babi, Teora Nam Krishna, right? So now the first Krishna is black and the second Krishna is the name. So in the same sentence, I have used the same word, once as a name, once as a common word. And this is very, very easy for any one of us to construct such examples. In English, in European languages, you get this Jack, John, Margaret, Julifer, or Bob, etc. These are only names. These have got no meaning. So identifying names, etc. is much, much, much easier there, not in Indian language. Then we said sandhi and then samas. Indian languages are a lot of sandhi and samas. And in fact, sandhi is within a samas, sandhi is outside a samas. So even to understand whether this is a samas with a sandhi or just a sandhi, or whether I should break it or not, I don't know. Right? It's a very, very hard problem in general. Other languages, German has this samas bit, but it doesn't have sandhi so much. So when if you get a long word, it's most likely a samas only. But in Indian languages, it can be both a sandhi or a samas. Then the languages, the Indian languages are quite common to each other than what we realize. Actually what we are taught, etc. This north-south divide, that there is this Indo-European languages, and then these Dravidian languages, they are all very different. This is not very well founded actually. There is quite common, and I'll give you some small features that to see that these are common, right? First of all, 80 to 90% of the vocabulary is common. So because most of these other languages have come from Sanskrit, have a very strong Sanskrit background, therefore the vocabulary, and so in fact in Ahomia, in Bangla also, you can take almost any Sanskrit noun and use it. This will not be wrong. I think 95% of the cases I can guarantee it will not be wrong. Okay, because it's just so, and that is true for most other languages. Tamil, it is often said that there is a difference, but again with Tamil and Sanskrit also there is about 60% common vocabulary. Okay, so this vocabulary is a very common thing. Then our order of sentences is subject, object, verb, as opposed to a subject, verb, object for English. So for example, moi bhat khao, ami bhat khai, this is always I eat rice, right? So I eat rice, but here I rice it, right? And this is true for Ahomia, for Bangla, for Sanskrit, for Tamil. Nan arichi sapudigiren, right? Now you also see this rice and rishi. This you can see the connection, right? Even if you don't know anything, if I just tell you that this is the name of a food, REC, you could have guessed this is rice. So the vocabulary, even if it is not exactly the same, you can kind of guess. Okay, and the subject object verb is a strong phenomenon that is common for all Indian languages, almost all. Then lack of articles. In English we have this A and B. To the best of my knowledge, most of the major Indian languages do not have that. Ahomia and Bangla have this phenomenon called cheleta, cheleto, all those kind of things, but that is coming from a different angle. It is almost like this da boy, but it actually is coming from this fact that the whole of the boy kind of thing. So yeah, and in most other languages it is absolutely absent. Then there are verbals. So there are nouns that act like verbs. So what do I mean they're nouns? They are nouns because they take these noun suffixes, right? So for example, khawata, right? So khobato, right? So khawata, meaning it's khawa, is from this verb khawa, the eating, and this eating, right? This is being made a noun, and therefore I can use all the noun suffixes, pratyas to this, correct? And this is common across all Indian languages. Then verbs generated from nouns. So nouns acting like verbs is very common, but the other way around is much less common. So that is also a feature. It's much less common. So in English, it is more common. So batting, cycling, all of this. You can take a noun and make a, what do you call this, gerund, infinitive, these kind of things you can make it. In Indian languages, this can be also done, but it is less common. So in Indian languages, this is rather we are more worried about what is called the samapika versus asamapika kriya, right? Samapika is something that I've done, right? So moi bhat khao, meaning I eat rice. So eating here is complete, but here moi bhat khaba lai yao, meaning while eating I am going, right? So khaba lai, that is asamapika. So I just cannot end the sentence there. It is asamapta, right? It is incomplete. I need another verb to complete this. So I'm while going, I'm eating, this kind of thing. Right? Yeah. Okay. So then another common problem or another common mistake that people do mostly is that they take the script as the language. So for example, when I say I show somebody this something written and say which is it, they said Hindi. Why? Because it is written in Devanagari. Now this is a very, very, very wrong thing. So language and script are almost orthogonal issues. So I can, for example, write Sanskrit in this Bengali Assamese script. In fact, in Bengal, there are many, many such puthis available where the language is Sanskrit and the script is Bengali. Because language and script are different things. I can choose to write down Ahomia in Devanagari. I can choose to write down Ahomia in even Roman. See, I have been writing Ahomia in Roman, right? You all understand that this is Ahomia. But this is definitely not the Ahomia script. So the script and language are different things. And there is this problem called, there is this issue called transliteration, which is just changing the script, and that is what I have been used. I actually wrote down in Ahomia, and then I did this transliteration to this, what is called the ISO 15919 scheme, right? And then it comes out like this. Okay. So it is just changing the script. Transliteration is not changing the language, which is translation. And then there are different transliteration schemes, and then there are different transliteration tools and resources. Why am I listing it? Because there is, again, many people who doesn't use languages, they said, oh, but all that is fine. But you see, I can't even type Ahomia. I don't even know how to type Devanagari. I only have an English keyboard in my things. Therefore, I'd rather work with English. This is no longer an excuse. This could have been an excuse 30 years back. No longer an excuse. This is as easy. You just have to make an effort of just doing one couple of things in your laptop, desktop, whatever, mobile, all of these things, right? Okay. With mobiles, this has become even easier. In particular, I would like to point out this Aksharmukh browser plugin, where you go and you can just say, you go to this website and you can type in anything and it will transliterate it, or there's a plugin. So you open up any web page and you enable that plugin, it will transliterate it for you, right? So yeah, okay. Okay, now some more important things, the roadmap ahead. How AI we have seen, Indian languages, we have seen languages in general. So what is the roadmap ahead? Is that, remember, corpus, deep learning models are always built from a corpus, right? Therefore, the quality of corpus is extremely important. Unfortunately, most available Indian language corpora are from these newspapers, blogs, social media posts, etc. Because they're very easy to collect. You can just web scrape. Now, because of this, these corpora are full of errors, non-native words, scripts, etc. Hence, the language that you learn, the models that you learn, are not up to the quality mark. Now, think of it, this is, while you were learning it in school, your Ahomia, you were made to read literature. You were made to write things, right? You were not just made to read newspapers or blogs, etc. Right? That would not be learning Ahomia correctly. Right? In fact, newspapers have this problem that the vocabulary size is very small, and you are always using it, the immediate past tense kind of thing. So you understand that there is the language variety nuances get down. So the best way to do it is the literature corpus. It has got a richer vocabulary, it uses all the language features, etc. And we have done it for Bangla, and we have seen that it requires also less number of model features. The size of the models, finally, the deep learning models, you can use much lesser models to achieve what bigger models can do. And if you add a bit of literature data over non-literature corpus, it results in a large gain. So if you add a little bit of quality to something general, it makes a lot of sense. So corpus quality is something very, very important that we should probably realize. Then there is this problem of cross-lingual transfer. So languages with similar features and script can gain a lot from each other, essentially. So if you have a large Hindi corpus, maybe Marathi can use it. If you have a Bangla corpus, maybe Ahomia can use it. Maybe if you have an Ahomia corpus, Bangla can use it, because they have very similar features and very similar script. In particular, the dependency parsing, let's not worry too much about what dependency parsing is. It's essentially some relationships between words. For example, this Karak relations, Upama, Rupak, Kriya, and all of this. This is, again, our initial findings, experiments show that given a translation between Indian languages, the dependency parsing tree, the relationships are exactly the same for most of the cases. So for 90 to 95% of the cases, the relationships are exactly the same. Therefore, if you understand a sentence in Ahomia with its relationship between the words, a little more deeper understanding, just take that structure and replace it word by word in Bangla or Hindi, you will get almost 90% of the time, you will get a correct translation. This is a very big, important thing. In fact, that is how languages should be learned. We should be able to use languages and translate between these things. Instruction finding, it can be also used in instruction fine-tuning, this parallel sentences, translation, and all of that. Grammar rules, many of the languages have very similar grammar rules, much more similar than other things. For example, Ahomia and Bangla are very similar grammar rules. The verb forms are singular, plural, the same. It's not so for other languages. So now, something just to touch upon, there is this BhartGPT project. I am part of that. There is not much to talk about it because this has just started, but I'll tell you the overall idea and how it can benefit in future from participation of all of you. So BhartGPT, the overall idea is that this is India's own generative AI chatbot. And it is not just English, of course, and it is in all the multiple languages of India. And why do we need it? It's kind of obvious, but still, we need India-specific context. We need to capture the cultural nuances. We need India-specific corpus, for example, legal and all of these things. We need our whole Dharma, Shastra, all of this that is not captured in ChatGPT at all. And then there is something called this Indian knowledge system. You may or may not have heard the term. IKS is an emerging field, but essentially you're trying to see what are the knowledge systems, what are the different kinds of technical text and also dharma text and all of these things that was there in ancient India and trying to understand from them. So BhartGPT, that is the thing. The issues we are currently facing is that enormous computing hardware is needed. This is exactly where we are stuck. We need GPUs essentially. Then quality corpora need to be collected. The corpora that we have from newspapers, etc., we don't want to just use it blindly because then it will end up in a very bad BhartGPT model. We don't want that. We want a nice corpora and nice so that the final model that is built is correct, right? And therefore, we require involvement of native speakers. Native speakers can help in multiple ways. They can create data sets, they can create benchmarks, they can annotate a lot of these things, they can tell us what the grammar rules are and the nuances of grammar, etc. And in addition to the corpora, this can help. And just to end that, one is this: just given a corpora, you will learn it. The other is augment the corpora with these grammar rules, language-specific rules, etc. That helps a lot. Therefore, these language-specific rules should come from the native speakers who understands this. And that is where the BhartGPT project stands, and that is where anybody who is willing to help will be very, very welcome. Okay, let me conclude. Language is actually one of the richest diversities of India. Culture, this is actually an opportunity, not a roadblock, to learn different cultures, etc. And if we don't do it, then nobody will do it for us. Then that's the whole point. And it is for us to see how we can use these technological advances for spread and preservation of our language, essentially, language heritage. This is just trying to write Dhanyavad in different scripts. And you can also see, this is on many of the languages, and you can see the same word is used. Dhanyavad is used, almost the same thing. Gujarati uses Abhar, which also probably we can understand. And Tamil and Malayalam uses Nandri, which is Nandri and Nandi is the same thing. But, so the vocabulary is actually very same. Yeah, I end here, and I'd like some discussions and questions.
Hello, sir. Thank you for such an in-depth and insightful talk on this topic. We have a few questions on YouTube. Okay. So the first question we have is, with the current developments in generative AI, can newer models help us to generate texts with the main types of word meanings? Abhida, Lakshana, Vyanjana?
Very good question. Excellent question. I see Abhida is kind of easy, and that is what the default is. Lakshana we can still try to do, but Vyanjana, as I said, it's extremely difficult. Vyanjana is probably not possible with the current state of the art. In fact, Vyanjana is difficult for even human beings. Unless you know a lot of the context and all of these things, it's very, very difficult to understand the Vyanjana. Abhida, surely we can do. Lakshana maybe, but Vyanjana at this point, no. But it's a very, very important, good question actually, yeah.
Thank you, sir. So the next question is, first of all, they appreciate your talk, and then they ask, what are the basic language concepts one should learn before learning and developing Indian language-specific NLP technology?
Okay. Again, this is a very important question, I think. Yeah. See, as a native speaker, you will probably know many of the language features, but the problem is that we probably do not pause and think that this is a language feature and try to think of this way. So my suggestion is that if you really want to work on languages, it is important to understand a bit of grammar of that language. And we can start with very simple things. For example, just this morphology, right? That what is a word? How is a word, for example, constructed? So let's take this thing, manushatva, right? So you have manusha and you added twa, and it became, so from manusha, you have made it another noun, right? And so this twa is a thing that can attach itself to many such things and can make it, right? So this understanding that therefore I can treat manushata as one word, or I can treat it like a sum of two things, sum of two concepts. These nuances understanding is very important. Plus, of course, the standard rules that, I mean, if I use moi versus if I use ami, what are the grammar, I mean, what are the pratyas I can use, what is the singular pratyay, what is the plural pratyay, etc. that I can use, etc. So a little bit of grammar, little bit of understanding is important. And this overall, I think more, I mean, so the grammar rules, I think, I'm sure all of us can pick up. The more important thing is to be aware that there are constructs in Indian theories, etc., that nothing is by chance, right? There are all, a lot of thought has gone behind the grammar of each of these things, right? And just appreciating that, and then the rest of it will probably follow.
Yeah. Okay. Thank you, sir, for that answer. Now, some more questions. The next question is, okay, so this is again all about LLM, since they are all the hype right now. How to add cultural / traditional nuances in LLMs, and like how to unlearn something from the base models.
Yeah, excellent question. Excellent question. So again, I'll ask the unlearning. I'll answer the unlearning part first. Unlearning in LLMs is almost impossible. Okay, once it has looked at a corpus, it has digested, and it is extremely difficult to unlearn. Again, think of it not in terms of a computer science problem, but in terms of a human problem. Think how difficult it is for us to unlearn something. It may be much easier to learn something new, but to unlearn something is extremely difficult, right? So unlearning is a big problem. Now I will connect back to the learning part. Therefore, see, we all know ChatGPT, etc., is very much culturally biased against India. You can see there are lots of examples, etc. Now, there are two ways of doing it. Either is that you add India-specific cultural context, all these other contexts to this, so that it knows, I mean, it keeps on learning it. Other is you start with a clean corpus. You start with a corpus where you will not need to unlearn, because you're starting with a clean corpus. You start with a corpus that is that has these generic things plus the India-specific context and all of these things. This IKS, this Indian knowledge system, this whole field and the researchers working in that has one of these goals as the main goal. Right? For example, I'll give an example from IKS. Right? We all know what a Pythagoras theorem is, right? We can all blurt it out. Any class 5 student can say in a right angle triangle, a square plus b square equal to c square. Actually, this sutra is from Bodhayan Sulba Sutra. Bodhayan Sulba Sutra is about 3,000 years, well, at least 2,000 years or 3,000 years earlier than current time, and maybe even earlier, right? We are not taught about this Bodhayan Sutra. Even if I now put it into this, and if I ask this question to a ChatGPT that has got both the versions, saying, tell me what this theorem is, it will keep on answering Pythagoras theorem, because it cannot unlearn, right? But if you start with only an IKS content, where I take only this, let's say the Indian knowledge system, text, corpora, etc., then if you ask this question, it will say this is Bodhayan Sutra, it is coming from Sulba Sutra. So coming to the crux of it, that is, BhartGPT has one of these goals. So we have to, our corpora have to be very, very correct. It's not so much the work of the the architecture or the process, etc., it's not so much important as the corpus. Okay, I hope I have answered at least to some degree question.
Yeah, you have, sir. So the next question is rather technical and very specific, but the question is, if someone wants to build or like fine tune from an existing LLM, like a model for a low resource Indian language, where suppose a limited setup 80 GB of GPU, task like maybe domain specific something, what will be your suggestion to start?
If I get the question correctly, is that you're using LLM to tune, right? Fine tune something, correct?
Yes, sir.
LLMs, so this instruction chatbots can actually, if you give it an instruction to generate training examples, it will actually generate training examples, right? Which can be then used to fine tune. But the question is, the training examples that it generates, how correct they are, how good they are, it may be a concern. But that is one part of the answer. The other part is 80 gigabytes is actually fine for most fine-tuning tasks, because you see, fine-tuning does not require much of a memory and GPU compute power. Of course, it requires, compared to CPU, etc., it does require, but not as much as what we call the pre-training or building the models, etc. So fine-tuning may still be done, but again, for fine-tuning, the training quality, the quality of the training examples is important. So 80 gigabytes, see, we are all struggling for this GPU resource constraint. But 80 gigabyte, I would say, is quite, it's not low at all. So you can try a lot of things, yeah.
Yes, sir. Like I can tell you from personal experience that is quite a lot. Yeah. So, okay. The next question is, rather general. It's given the richness of Indian languages, is there a way to estimate information content in a given Sanskrit versus corresponding English sentence?
Yeah, there is. In fact, there is a good question. There are some studies in that sense. Couple of things is, again, the information content can be measured in multiple ways. One is using the standard entropy, etc., all of these things, the complexity, etc., all of these things. The other is the vocabulary, the richness of the vocabulary, etc., and the nuances, the kind of different constructs that you are trying to use, the kind of different this dependency relationships that you are trying to use, etc. The problem is that these are all handmade studies. People have made handmade studies, and it has been, at least anecdotally, Sanskrit is much richer than English. But now, if you put me on the spot and say you prove it, it will be hard for me. As I said, these are anecdotal examples of some things, etc. For example, you take some corpus where the translation is there for both the things, and you see. Also, one important thing is that in general, Indian languages are typically shorter than English. So if you try to, the number of words that you may use, or the number of, the length of a sentence, because Indian languages are much more productive in the sense that you can use this pratyas, you can use this verb to noun feature, and all of these things. Typically, they are shorter than the English thing, because English has this point of prepositions, right? If you go back to this sentence, right? This is this Rajshabate Rajai Brahmana Shakalaka Dhan dichilo, right? So this means a king is donating whatever money to Brahmans in Rajsabha. You can make it. This is a quintessential example of all the things. If you try to write it in English, there will be many words, because it's two Brahmans in this thing, of that, all of this. So therefore richness wise, so whenever you break down into these small parts, etc., the richness kind of falls down. And then there are this something called a language perplexity measure, right? Which is again a very computer science notion. It uses some calculations to say, for a model, for a corpus, for a model, how complex your model is. And in general, so Sanskrit is much more rich. The vocabulary is much higher, and the corpus, the available corpus, is also much higher. But yeah, so
Okay, thank you, sir. Sir, I'll try to combine a couple of next questions. There's one. Here's one. So, what strategies can be
Punabrat,
employed? Yes, hello.
I think that question is already answered. It's mine question. So
Okay,
maybe you
okay,
can take others' question first. Maybe
okay,
that
sure.
will be better. Yeah.
You
So,
can take the questions.
okay,
I'm fine. Yeah.
okay. So, the next one is what are some ethical considerations? Like, just a brief question. Uh, we need to keep in mind while developing AI technology, especially for Indian languages, especially culture, considering the cultural sensitivity.
Yeah. Again, cultural sensitivity is an important issue, and so jailbreaking is of course one phenomenon where there is an ethical concern in the sense of immoral things or illegal things, but the cultural sensitivity is actually is a big problem with current models. And these are well known, right? That for certain languages, for certain religions, if you ask certain questions, it refuses to answer, but for certain other religions, it happily answers. This is actually cultural callousness in terms of the current chat GPT and other models, right? So we don't want our Bharat GPT to be having the same callousness or the same indifference or this thing. Now, one thing, so the cultural context is an extremely important thing, but it's also a very hard thing to understand. Uh, in the sense that, see, as an Indian, I may be knowing some of the cultural sensitivities of Indians, but suppose I am trying to build this model for a foreign language. I may not even understand that I'm hurting them culturally or I'm hurting them something, right? Therefore, it is also important that while we are building these Bharat GPT models, while we are collecting corpus, while we are checking the outputs of all of these models, we have these probes to see whether this is sensitive enough, while it is culturally sensitive enough or not. So these are actually hard questions. See, there is no known methodology to do it. So the challenges in front of Bharat GPT is all of that. So we just don't want another chat GPT for Indian languages. No, that's not the idea. We want all of these nicer features, safety plugins, all of these cultural nuances, context. I mean the India specific nuances. All of this trying to build into it. Yeah.
Okay, thank you, sir. So the next couple of questions are about Bharat GPT. So one is like, what are some of the languages that will be included in Bharat GPT, and also how does Bharat GPT intend to support like the various languages and dialects which are spoken in India, as there is like not too much difference between some dialects. How will it not be confused between them?
Correct. Again, I will answer the second question first about dialects. Now, dialects is an extremely difficult thing to collect in any language, because you see, dialects are mostly speaking changes, right? When you write down, at least in Bengali, what happens, I do not know enough about Ahom literature, but in Bangla literature, when you write down, you use a canonical form of Bangla, right? So you cannot really make out the dialects. Now, to make out the dialects, you need to capture either this folk song data or actually speech data. Now, one important thing that I have been deliberately avoiding speaking about is the speech data. You see, as I said, language is mostly about speech and more about speech rather than about text, right? So therefore, to understand the differences between dialects, we have to have speech data, and we need to transcribe them to text to understand the difference between dialects. This is number one. Number two is languages. What are the languages we are typically doing? Yeah, I mean, of course, I'd like to say the 22 major languages of India, but I don't think we have enough data for it. But all the major languages, otherwise, I think the 12 or 14 major languages for which there's enough number of speakers, enough number of written material as well. So we are trying to do all of that. I mean, that's at least the stated goal. Yeah, for Bharat GPT. It includes Ahomia, Bangla, and all of this.
Yeah, thank you, sir. And finally, someone from New Jersey says, "Hoopawat to you. Good morning." And they thank you very much for your time, and they say that it is your talk was very impressive. Now, due to like time constraints, I think we would like to wrap up
we can, if there are some more questions, I'm happy to stay and answer. This is quite
Okay.
for me.
Okay. So first of all, so the person from New Jersey itself, they ask, what? 1 second. Give me 1 second. Where is it? How will LLMs or like in general AI be read old Hasipat type of documents as image? Like, for example, lots of these like the ancient cultural texts and all, they would only be available as images, right? So how do we address that issue?
See, again, images can be processed by multimodal LLMs. If image is really an image, but I guess the question more about is this image is of a puthi or a script or a writing, correct? And we make some header tail out of it. As of now, the best is to try to OCR them, try to extract the text out of them, and then use the text. Directly using image of let's say a manuscript in a multimodal way, that's actually a good pointer. I have not thought about it. I don't think it is going to be very productive, but this can we just try it out? Yeah, but as I said, right now the efforts are more in terms of converting it into text and doing it. And again, one important thing that all of us can help, native speakers can help, is there is a lot of such manuscripts, right? Many of these manuscripts, the OCR, because it's handwritten, because it's very old and all of these things, it may not give you good text results. One of the avenues is to just speak it out. So it may be easier to just see it for native readers. It may be easier to speak it out. And if there is a good speech to text engine, then that produces the corresponding text. So that may be another thing. So therefore, I said we require a lot of volunteers for many of these tasks.
Yes, certainly, sir. Like, I know from personal experience that that is what we need to do, especially in the case of SMEs, given the quality of corporate I have found in my thesis so far. So with this, I'd like to present the concluding remarks. And with this, so hello everyone. Again, on behalf of Assam AI Initiative, I'd like to thank Professor Arnab for the really insightful and amazing talk about how the current AI wave can help Indian languages and how we just really are lagging behind in this avenue. It was really interesting to learn about the amazing things AI can do, but at the same time, the challenges we need to overcome to make it work for the various differences and richness of the languages we speak in India. I really liked how Sir explained how the cultural richness and nuance of various words might be lost in translation, like how you spoke about fire and how ChatGPT and other LLMs that are being released now can mix up Indian languages such as Sanskrit and Hindi. I feel we all need to remember that we all can and definitely should play a part, and I feel it is like our duty to play a part in shaping the future of Indian languages in this new world of AI. If you are interested, I'd encourage you to please join us at Assam AI Initiative. You can find us online. I'll in fact share the link in the chat for our website. And we have this whole community dedicated to especially enhancing the future of Indian languages, especially Assamese. And once again, sir, thank you, Arnab sir, and everyone who joined us today for this talk. With this, I'd like to conclude our session today.
Thank you very much.
Thank you,
it
sir.
was also very useful for me because these questions, etc., all of this are
Thank you, sir. I think Sisita, maybe you can close the YouTube session, and maybe a few minutes we can talk with sir online. Sir, is that okay?
yeah, sure. No problem.
Okay, sir. So